Hey everyone, Billy from Precision Reaction here today talking rollout time. I get a lot of questions about rollout time, so I want to go in depth on how we get this number and where this all started. So, simple question, where did it start? It all started because I got in a slump and I sucked. I was rolling off 20s and 30s, couldn't find the tree, started blaming the car, and then, we started blowing through money, and I didn't, all the time and entry fees just wasn't worth it. I'm like, why isn't there anything to measure, what the delay box did and how the car left the beam? Like, was the car consistent or not during that time? And so that's kind of the path I went down. I'm a racer just like you guys. I didn't want to make something that was, made us overthink. I want something that's going to make us not think. And so that was the whole point of this. It has a auto start feature, so you basically set it up in the car and you don't touch it. It just rattles off runs and stores them for has a 30 run log on it. So I want something that was passive, and if you got in a slump, you can look at it and make sure your car's good. If your car moves around like 5 to 10 thou, I'm not good enough to detect that. So I wanted something that was accurate enough. We got it down to plus or minus 1 thou. I wanted something accurate enough to tell me if the car was moving around. I can quickly make that change and fix it before I go through half a season of entry fees trying to chase the car. But it's pretty simple. You just mount it right to your car. It's got an aluminum saddle underneath. So you hose clamp that right to a chassis. You mount it face up. You got 4 connections here: power, ground, 12 and 16 volt compatible. And then you got a connection to your button and a connection to your trans-brake solenoid terminals on your delay box. So all it does is it looks like your button terminal and your trans-brake terminal. So when I hit the button and I'm staged, and say the box is configured to go high, you can configure this either way for any delay box. So I'm on the button, trans-brake's also high. I let go of the button so it sees the drop on the button, and then when the delay box runs out, trans-brake goes low. It sees the drop on the trans-brake solenoid. That is your delay time. All right, so that's the delay function. And then after that, it goes into a burst log of 2,000 samples per second of acceleration. And so you get a lot of noise, but no acceleration for like 20 thousandths of a second. And then you'll get pretty steep rise in acceleration. You get some peaks and valleys. You get a pretty large drop when the tires break loose. Some test data from the rollout logger. This is 1 second of test data of 2,000 samples per second. A couple runs laid over each other. And you got the first 30 thousandths, 40 thousandths of a second where there's nothing happens. And then it cracks the tire, wrinkles the tire, and then breaks the tire loose right here. And what we do is we go from acceleration to position. So we just convert that with the equations of motion. I'm not going to go into that, but I'll show you what it looks like. So on the right here, you got an axis of the position of the car. So this is where the car starts. And then what you do in the rollout logger is you set what your car's rollout distance is. So on your front tire, right, here's the stage beam height, about 1.5 inches or 1.9 inches. How far that beam has to travel across that tire. That's what your rollout distance is. So all we're trying to do is to see how consistent the car is moving in that first 12 inches every run. Is it within a thou or is it moving around? And so what that'll look like in position to the rollout logger is a curve like this. And so when we set a trigger of 11.5 inches, it'll just see when it hits that 11.5 inches, it basically stops recording and then looks down at what the time was when that happened. And then that is our rollout time. And then the next thing was if I have, say a rollout time of 2:05 in my car, and it changes to 2:10. All right, well, that's great. My car's moving around, but what do I do? How do I fix it? So we incorporated a dead time feature as well. So we put a little trigger here at 1/2 G, which you can adjust this as well. And we can see when the G meter hits 1/2 G, looks at where that time is, all right, and that's our dead time. So this can decipher from one run to another, was the dead time the same or was the rollout time the same? If the dead time was the same, that means you had a graph that looked something like this. So, you know, the black line would be 205 and the red line would be 210. So that's telling me that, you know, the trans-brake solenoid was fine. The car, there was no delay here in rise and G-force, so it cracked the tire exactly the same. But after it cracked the tire, there was less acceleration. So the car didn't break the beam as quickly, and that's why you got 210. And that would be like if you had a dead time of 030 and 031 or something like that, like they're the same. And contrary to that, if it was like 030 on the first pass and 034 on the second pass, and then that's telling us that, you know, the peaks and valleys were the same, but you had a delay in dead time that caused your 210 or your delay in reaction time. So that's how you can decipher if it's the tires, if the peaks and valleys are different, or if it's a trans-brake solenoid with your dead time being different. And it could be the valve body or the solenoid. Like what I'm saying is it could be that area if you got this scenario, and if it's the other area, then you got the tires. It could be the track. I'd see the track all the time make a difference. So hope that makes sense. If you got any questions, give me a call. Check out our Facebook page, precisionreaction.com. You can give me a call or send me an email, either way. Thanks a lot for watching.